Welcome to classes on organic chemistry. Today's class is class number 11 and it is the continuation of class number 10. The class is on general organic chemistry first year and it is elimination and addition reaction. The most interesting fact on these classes are that you need not learn anything, you just follow the class and it is the backbone. Very often I use the term backbone and you have only the scope to learn the reactions and their mechanism only in first year. Those who do not have the idea on this one, in second year they will face a lot and they can't understand anything and they will learn and prepare for competitive exam or class exams only in year. They don't have any base. So you please patiently follow my classes and without learning, without seeing or writing anything over and over again, you just follow and see and you will be the king of chemistry. It's my assurance, it's my suggestion. So first one, I will start with addition reaction. Addition means you will add something. You will add something means there should be some unsaturation. So unsaturated compound will show, hydrocarbon will show addition reaction. So unsaturated hydrocarbons, where there is double bond or where there is triple bond or where there is CO bond, etc., will show addition reaction. These are the signals of the carbohydrates. Having these groups will very often show addition reaction. Now here addition means you will add something and there is no substitution, that you will substitute, you will release something. Nothing is required, just you will add. Now when you will add something, so there will be the question of bond. If it is double bond or triple bond or like this, you will add something and in its place you will add in pi bond. Am I right? So one pi bond will vanish. One pi bond will vanish. One pi bond removes. And in turn, two pi bond will appear. To balance it, balance it. Two sigma bond appear. This is the facts. One pi bond, see, if anything is added, say bromine, here bromine and here bromine, you remove one pi bond and in turn you give two sigma bond and give bromine and bromine. This is the fact, nothing else. So now let me come to the type of addition reaction. Number one, nucleophilic addition. Number two, electrophilic addition. And number three, free radical addition. You don't be confused. You don't be think that the matter is very lengthy. Just you follow and go on my class. Go with my class. You will find each and everything is very easy and your future scope of learning chemistry will be too much interesting. So out of this, I will first start with elimination reaction. So before that, you have learned what is electrophile. The species which are deficient of electron or plus charge are the electrophiles. And why they are electrophiles? Because they love electron. And where the species are double bond or triple bond or CO bond have pi electron, mobile pi electrons, and they are rich in pi electron. That's why the electrophile which are deficient in electron will love this site to attack. So now let us take one example, electrophilic addition. One electrophile will added in the unsaturated hydrocarbon. Let us take one example, CH3 bond. I have shown nothing, but just have taken an alkene. That alkene is unsymmetric. If double bond on the both side of double bond number of carbon atom are different, then it is unsymmetric. I have taken unsymmetric. You can take symmetric also, but there is a problem with unsymmetric hydrocarbon. That's why I have taken an unsymmetric. So what happened? I have done. So I have lost this single bond, and in its place I have given one bond here and one bond here. I have given one bond here and one bond here. Here bromine and here hydrogen. Here bromine of this, here hydrogen of this. This is addition. So one pi bond breaks in the formation of two sigma bond. One sigma bond here with bromine, other sigma bond here with that carbon. Am I right? Now I am very interested for mechanism. Am I right? Let me show in short the mechanism. What is the mechanism? So you see that is CH3 CH double bond CH2 number one. So what's happened here, in the earlier classes I have shown you electromagnetic effect. Am I right? So temporary displacement of displacement electron, I have before that class I have told you this one. So there will be withdrawn of electron will be withdrawn from bond to atom. Now problem is that if there is inductive effect, two effect is here. One is electronic displacement and other it is accompanied with plus I effect. It is pumping electron. So bond will be withdrawn in this way, not in that way, because this is pumping electron in this direction. If plus I effect is there, so withdrawal will be in this way, not in reverse. Mind that. I have not mentioned it in earlier classes. So bond will be withdrawn in this way. So if bond is withdrawn, means there is a negative charge. Am I right? So that negative charge from here, this will plus. First step is protonation. This is plus. Am I right? So that is negative. You assume it negative. That negative will try to attach with this one. Am I right? So this bond arrow means a bond. This arrow means a bond. So you are getting CH3 CH, that double bond will become single bond, and CH2, and that bond has I have written CH3. One is CH2 and other bond is made with C and H, that is CH3. Now consequently what happens is become this, it is carbocation. Very interesting, very interesting. Now you bring this carbocation here, CH3 plus CH3 plus that negative charge now always bond from negative to positive. Mind that will attack upon this one. So what will happen? CH3 CH Br CH3. What I have written the result is this. Am I right? So if it is CH2 double bond CH2 and it is HBr, same CH2 double bond CH2 and if it is HBr, so in any place you add H and in other place you add Br. Am I right? Again I am taking the example CH3 CH double bond CH2 HBr. Mind that there is a very famous reaction, Markovnikov's or Koff's, it is same. Markovnikov's addition or Markovnikov's addition is same. It is given in your book. Am I right? I am explaining with the same mechanism which I have already done, but there is a bit twist. So what's happened here is Markovnikov rule means here again bromine will be here and one H will be there, but it is a rule where it is told that if the first condition of Markovnikov rule is that your alkene should be unsymmetric. If it is symmetric on double bond, both sides of double bond, carbon number of carbon atom is same, it is of no use. It should be unsymmetric. That's why I have taken propene. And your addendum is also it is HBr. Am I right? So this is plus and this is minus. So what Markovnikov tells that the addition will be in such a way that negative part of the addendum will get attached to the carbon on double bond which has less number of hydrogen. So what is the rule? CH3 CH Br is the negative and it is going to be attached with the carbon on both sides of double bond which has less number of hydrogen. That carbon has less number of hydrogen and that negative part will added with this one and positive part will get attached with the more number of hydrogen atom. That is Markovnikov rule. So condition is that it is unsymmetric, addendum is also unsymmetric, it is not Br2. It is not Cl2. It is HBr type. So that is called Markovnikov rule. And earlier was one, I was given the mechanism, and that is given by Markovnikov, and it is Markovnikov's rule. But what's happened? The interesting fact is that if it is anti-Markovnikov, anti or Kras effect or peroxide, if you are given the same reaction or substrate may be other type, unsymmetric, and HBr is given, and here in the above you just minutely follow what is given in the error. In the error, if it is given peroxide, organic peroxide, C6H5CO whole thing 2 O2, this is peroxide, it is organic peroxide. If that both substance is given on the error, mind that you don't add easily as you have done in Markovnikov rule. It will be the reverse of Markovnikov rule. So what's happened here? Earlier we have added bromine to that one, negative part get attached with the carbon having less number of hydrogen. Now it will be reversed. Negative part will get attached to the more number of hydrogen, and positive plus will get attached here. Just reverse. And that mechanism is actually free radical mechanism. You mind it. If I get time, I will show you. It is free radical mechanism. But there is a question, a critical question very often asked in entrance also in your class exam. If I give you same thing, same substrate with HCl, same thing. So will HCl will follow addition as anti-Markovnikov in presence of peroxide? That is, Cl will get attached with this and hydrogen will get attached with this one. In its place Cl, and this is CH2. Will it follow this one? Answer: exactly not. Certainly not. Why? Because it is a free radical mechanism. HCl never breaks as H dot and Cl dot. HCl never generate free radical. It always becomes H plus and Cl negative. Since it never breaks in presence of peroxide as H dot and Cl dot, so it will not follow that mechanism. It will again follow the usual earlier Markovnikov. Though it is given peroxide or organic peroxide, yet if it is HCl, again your answer will be CH3, CH, Cl, CH3. What Markovnikov tells? Mind that you will be confused if HCl is added with this, the same thing HCl and peroxide will be given. You don't follow that anti of Markovnikov. It will be same as Markovnikov, because HCl will never breaks as homolytic bond fission to give H dot and Cl dot due to high electronegativity difference. That's why HCl will in presence of peroxide will again follow Markovnikov rule. Now what is about HI? If it is given HI with the same substrate and same peroxide, will it again follow anti-Markovnikov? Answer: no, it will not follow anything. Here HI certainly will give you free radical, but despite attacking the free radical, attacking the substrate by this free radical, iodine prefers to add up with another free radical to give I2. Hence, with I2, the reaction will not proceed, because I2 means I dot free radical is exactly forms, but that I dot again combines with another I dot to give I2, besides attacking instead of attacking the substrate to give the result. So with HCl and HI, we don't get any with HCl we don't get any anti-Markovnikov product in presence of peroxide. Only that is possible in case of HBr, and also in HI, though I dot is produced, that I dot doesn't react with the substrate, it itself combine with another I dot to give I2. Say CH2 double bond, CH2 plus Br2. Again here bromine backs up into Br plus and Br negative. Now what will be answer? It is also electrophilic addition, but here one bromine will go in this way. One bromine here, another bromine here. No difficulty is there. You can very easily answer the question. But one of the question in entrance also in the class is used that the reddish pink color of the bromine disappears or fades away when it is made to react with alkene. Its color vanishes. That implies that the substrate is alkene. So it is an important test of unsaturation. If a compound is unsaturation, the reddish pink color of the bromine fades away. That implies that the substrate is alkene. If it is alkane, CH3 dot bond CH3, and if you made to react with bromine, the color of bromine does not disappear because it does not react. It means that the substance is saturated hydrocarbon. So if it is saturated, no color of bromine will fade away. If it is unsaturated, by that type of reaction it fades away. So bromine water is used as a distinguishing test between saturated and unsaturated hydrocarbon. One of the important reaction, another important reaction of cis form, when the groups or atoms of the same type on the same side of double bond, it is called cis. And if it is CH3 here and if CH3 is here, it is in opposite side, it is called trans. Actually it is 1 2 3 4 butene, it is cis. The answer is, I am showing the answer, no matter, and remove one pi bond. One pi bond remove means 2 sigma bond. You remove one pi bond and give 1 sigma bond here, 1 sigma bond here, and give bromine here, bromine here. Your answer will be correct. But in entrance exam, sometimes it is asked which of the following product is correct answer. Each and every one, every product or given options will have bromine, 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 bromine. But the fashion of arrangement of bromine is different. That's why cis trans answer is correct. Now I am showing you how. First of all, from that bromine and bromine, one bromine, if it is Br2, that Br2, one bromine B plus, Br and Br, am I right? So when it breaks, one bromine double bond, one bromine comes here and becomes B plus. Am I right? So in the other hand, you are getting another negative. If one is plus and other is minus, so that minus will preferably attack from other side. It is blocked on formation of B plus, Br plus. So the nucleophile will prefer to attack from other side. That's why I have arranged it CH3CH. I have written CH3CH in the same part, and bromine. What's happened? If it is getting attached in this way, you are getting this. How? Because when you are adding this one from negative to this, means you are making a bond, that is bond. Am I right? You are making this bond. When you are making this bond, how many bonds are there? 1 2 3, and that is another type of bond. Am I right? So that bond will be withdrawn. If it is plus, plus vanishes. So whenever that, on addition of that bromide, that bond will be withdrawn to balance the valency of carbon. So that carbon has 4 valency, 1 2 3 and another hydrogen. So when it appears to here, so 1 2 3 and 4, this is 5 valency that will be withdrawn here to balance positive charge. So when it makes balance withdrawn this side, that bromine get attached permanently with that carbon. So we have got this one. That bromine here appears attached. When it is attached, and that part bromine. So bromine attached in other way. CH3CH, 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 and that bromine is attached to upper part, and that bromine detached from this become here. So we are getting trans product. So very often question is asked. So you can answer in this way. Nucleophilic addition reaction. Nucleophilic addition reaction. It is a type of the reaction where nucleophile, that is electron rich species, will attack upon the reaction center on carbon. Am I right? That generally occurs here, and in electromagnetic effect you have seen that in presence of the attacking reagent the bond is withdrawn in this way. So what we get? We get this as negative and this as positive. Am I right? So our main intention is to show nucleophilic addition. So let us take one example, and it is very, very important in higher secondary second year in aldehyde and ketone chapter. Very often you will come across with this one, and you will not be confused if you have knowledge beforehand in higher secondary first year. So this is ketone. Everybody of you know this is ketone. When I will make to reaction with HCN, so this is plus and this is minus. This is nucleophile. Am I right? So this nucleophile will prefer to attack the reaction center carbon, because carbon is positive. Am I right? So negative will try to attack this one. You see, mechanism is tremendously important, because if you have the knowledge and mechanism, you need not to learn anything by heart, and you need not to learn by practicing over and over again. Just to follow, no need to write, no need to say, just to see and watch the video, you can easily understand the facts of the chemistry, and so that chemistry will be very easy for you to learn. So if Cn is attached in this way, so that bond is withdrawn. That bond is withdrawn means this is negative. So that negative part will get attached with this positive part. What we are getting here is CH3, and here C, and that C here Cn is getting attached. I have told you when minus is attacked with this one means it makes a bond with this, forms a bond with this. So I have formed a bond with this carbon center, reaction center carbon. Now here in other hand, O is negative. Am I right? So in that negative part, that positive is get attached. So this is acetone cyanohydrin. And if you want to move one thing more, in my second year class, or sometimes I have forgotten, I have mentioned this thing is not, if it is water with acid, then CO group will become COOH group. So one step more I have showing you, you will get again in second year, very often this a conversion is asked. So from today onward, you should learn that when carbon Cn is acid hydrolyzed, means hydrolyzed in presence of water, in presence of acid, it gives C and becomes C double, other thing will remain the same. So this is nothing but nucleophilic addition, very simple, nothing more is given, and you will very often get this thing. I have rubbed it. Third one was free radical addition. Free radical addition is that is, if it is CH2 bond CH2, and if it is chlorine and it is H nu or ultraviolet light, UV light, whatever you use, so this is C dot, and that one dot will come here, one dot will come, and double bond will become single bond, chlorine will enter in this way. Very simple. Free radical mechanism will operate in presence of H nu or ultraviolet lights. So that free radical will get attached with this and this one, a double bond will back into bond. I will not show mechanism, you will be very often confused with mechanism in each and every steps. Okay, so I have mentioned three types of addition reaction. So one critical question, or sometimes it is not critical, if you can understand it is very simple things. I am showing you HCHO, CH3CHO, or CH3 C double bond O. If you break this, you will get HC double bond O H, you will get CH3 C double bond H, and this is this. And if I asked the addition of order of addition or increasing order of addition of nucleophilic addition, Cn will add up. Am I right? A bit earlier I have told you. What is the order of the reactivity? Which one will be faster, which one will be less quickly attacked by Cn? Which will go fast reaction with the Cn? You are asked to arrange in this way. Increasing order of reaction, nucleophilic addition with HCN or anything nucleophilic addition, the compounds are given HCHO, CH3, CH2. It is formaldehyde, it is acetaldehyde, it is acetone. Answer is very simple. You saw whenever more and more plus I effect is there, that positivity, that the reactivity of HCN, that is negative, is nucleophilic addition depends upon the more the positive charge on carbon, more easily it will attack. Am I right? So if you have some effect upon that carbon which vanishes or disappears or removes or lessens the positivity charge on carbon, that will not effectively attack. That part will not easily be attacked by cyanide, Cn negative nucleophile, because here H is has very least effect of pumping electron or nil effect in comparison to a plus I minus I effect. It is assumed to be 0. And when CH3 I effect is given, so with respect to this one here, this plus, if bond is withdrawn, this one, this is plus, and this positivity is decreased to some extent by plus I effect. So it is more positive carbon center than this one. Here again 2CH3 plus I group is pumping when it withdraws the electron, negative and plus. So positivity appears on carbon is at a greater extent is satisfied by plus I group. So more the plus I group, less is the chances of CN going to be attacked on this one. So it will be highly attracted by the order will be in this way. So on the way of my discussion, I have explained some of the questions answer, actual question answer of your book. So now very interesting fact, which is I challenge each and every one of you that nobody of you have the knowledge on elimination reaction. Elimination reaction. Many of you just have the knowledge elimination reaction, beta elimination. Everybody of you know beta elimination. Maximum of you do not have. Where from Hoffman, where from Sidjasef effect, where is orientation effect. Nobody has this knowledge. Elimination. What does mean elimination? Means something will be eliminated from the substrate. And now it is reverse of addition, where double bond, triple bond, addition occurs on double bond, triple bond, it becomes single bonded compound. But in case of elimination reaction, group or atom of the substrate will get released or removed, and in its place a double bond will appear. In other case, double bond becomes single bond. Here you will get single bond will become double bond or triple bond. It is reverse. So where there is elimination means from saturated you will get unsaturated. In a nutshell, you will tell that it is elimination reaction. So the compound having OH group, compound having HO3 group, compound having diazonium group, compound having that group. If you are having this compound, you will see that it is nothing but substrate having these groups will undergo elimination reaction. It will be eliminated. Now elimination reaction generally occurs in presence of a base, and this should be an alcoholic. Mind that it is very often you will get alcohol, potassium hydroxide alcohol, potassium hydroxide alcohol. When you will find this maximum in general, there may be some exception. In some cases you will get second-year, it will be elimination reaction. And potassium hydroxide, if it is aqueous, then it will be substitution reaction. OH will come here and other will go away, substitution. But in case of elimination, if it is not aqueous, if it is alcoholic, then nothing will add up, something will release from the substrate to give double bonded compound. So mind that potassium hydroxide is alcohol, answer will be a double bonded, triple bonded compound from the substrate. It will be elimination reaction. So elimination reaction, so this part is very important, you might need to follow, because very often you don't have the knowledge on this one. Elimination reaction is broadly classified into the alpha elimination reaction, and in second part it is beta elimination reaction. I am going to explain what is alpha elimination and beta elimination, but very often maximum of you know what is beta elimination, but you don't know what is alpha elimination. Elimination reaction is broadly classified into alpha elimination and beta elimination, and maximum of you do not have any knowledge on alpha elimination, and you know what is beta elimination. And so let me first explain what is alpha elimination. So you see this is chloroform CaCl3, and if you give potassium hydroxide alcoholic and if you give some heat, you will get, if you break this, you will find in this way CaCl3. Am I right? So that is alpha carbon, and that alpha carbon sometimes it is mentioned as 1 alpha 1. This is 1 carbon or alpha carbon, and next carbon beta carbon, next carbon gamma carbon, like this. So if the elimination occurs, some groups or atoms atoms or groups of atoms is released from the same carbon, alpha carbon, then it is alpha elimination, or it is 1-1 elimination, because from this you have removed two things. You are getting Cl, am I right? Cl2 and C lone pair this, so it is chloro dichlorocarbene. You will get it in Raman-Thaman reaction in higher secondary chemistry, and in entrance exam it is asked what is the intermediate used in the Raman-Thaman reaction, and it is not given exactly in your books. It is carbene, it is dichlorocarbene. So dichlorocarbene, what's happened? From that carbon, 2 chlorine has removed, am I right? 1 chlorine and 1 hydrogen has been removed, so you are getting 1 chlorine and 1 hydrogen removed, you are getting CCl2, am I right? That CCl2 lone pair and bond, that will give you dichlorocarbene, and since 2 things has been removed from 1 alpha or 1 carbon, so it is 1-1 alpha, 1-1 elimination or alpha elimination. It is very it is not very often mentioned in the general books. If you go on reading in higher books, you will find this one. So now coming with beta elimination. Now what is beta elimination? Beta elimination, say CH3 CH2 Cl. If you give a base, say this is base, so what's happened? That is already I have shown you, that is alpha carbon with which chlorine or bromine or iodine is attached, is called alpha or 1 number carbon number 1. If it is alpha, then this is beta, am I right? So what's happened here is, from that beta, 1 hydrogen is abstracted by this base, because in the first substitution class I have told you that a base is a nucleophile, a nucleophile is a base. A base sometimes abstract a hydrogen, but nucleophile attach with this. Here base is abstracting this proton, hence it is base, it is not nucleophile, base. So when it abstract 1 hydrogen from beta carbon, so that bond is withdrawn in this way, and that is removed. So what's happened here? You get HHCH2, HHCH2, and that bond on abstraction of that hydrogen by base is inclined towards right, so you are getting CH2, and this is removed, CH2 is in the picture, you are getting alkane. So this is beta elimination, since 1 beta hydrogen is abstracted by the double bond and eliminated product alkene, ethene is formed, hence it is called beta elimination. Now simply we have shown beta elimination, or it is 1-2 elimination. Why it is 1-2 elimination? Because from 1 position chlorine is removed and from 2 position hydrogen is removed. It is, that's why it is called 1-2 elimination. And it is another example of beta elimination has been classified E1, E2 and E1CB. So you don't know what is E1 elimination. Mind that when we are talking about E1, we should keep it in your mind SN1, because in second year you will get, there is often competition between elimination versus substitution, but nobody directly tells. Very often, sometimes people do not tell that what type of substitution and what type of elimination has competition. Answer: always competition between substitution and elimination is SN1 and E1. So if you don't have the knowledge on E1, how can you answer the competition between substitution reaction and elimination reaction? Always there is a competition between substitution and elimination. So substitution type SN1 and substitution type E1 are of competition. So SN1, what we got in SN1, there was carbocation formation. We got in SN1 reaction you see in E1 same carbocation formation and rate is so you see the similarity between SN1 SN2. We have got same things in SN1. Carbocation formation was there in SN1. Here also there will be carbocation. I will take an example, I will explain. And here rate is directly proportional to the substrate concentration of substrate, not on the concentration of the nucleophiles or attacking reagent. So it is mononuclear unimolecular substitution reaction. Am I right? So in E1 also it is E1, means only the rate of the reaction depends on the substrate, not on the concentration of the attacking reagent. So it is E1, and some similarity with SN1. You have seen in the when carbocation SN1 and formed, there was a chances of rearrangement of carbocation. So also in case of E1 there is carbocation formation, there is rearrangement of stable carbocation. If it is 2 degree and there is a chance of rearrangement to get 3 degree carbocation, so before attacking reagent it will get arranged first. So there is chances of rearrangement of carbocation in E1 also, same as SN1. So polar protic solvent favors the E1 SN1 reaction, E1 reaction. So also in SN1 reaction we have seen the solvent, if it is water, and it will favors. So these are the facts where how that is as to how the SN1 reaction, E1 reaction forwards. So let me take one example, same as SN1. We'll take this one. So what's happened? Actually, there is a transition state for very little time. I will not show you because this is plus and it will pump electron, and it will be plus because it will withdraws electron, it is minus plus. So thereby there is a star separation. So what's happened in the transition state? I am not showing you what's happened. This will be dot 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 dot. Am I right? So I am not showing transition state, but I am jumping over this one. I will show you. The C will leave. It is leaving group. It will leave out. Now question is that you will find that it is like SN1. It is 3 degree alkyl halide. You are getting carbocation. In E1 you are getting carbocation. Besides there was transition state, but we will overlook this one. We will show this one. Am I right? So we have seen there are also carbocation, but what is the difference of E1 and S1? Difference occurs here. You see, it is first step reaction. It is again second step. Like SN1, it is also 2-step reaction. What is second step reaction? Second step reaction is very interesting part. You minutely follow. So you have a base. That base will, in first SN1 reaction, it attack the carbon center and get attached. But here base will, here the nucleophile will attack as a base. It will abstract hydrogen, not attack. Nucleophile will attack, base will abstract. In SN1 it acts as a nucleophile, so it attaches to carbocation, so that base will attach. But in E1, base will not attack, it will abstract. Sorry. So what's happened here? You are getting simple. I have written this is double bond CH3 CH3. This is double bond CH3 CH3. We have got the result like this. So you have got a lots of similarity between SN1 and E1. In SN1 there was carbocation, in E1 there is carbocation. In SN1 it is 2-step reaction. Yes, in E1 it is 2-step reaction. In SN1 there is a chances of rearrangement. So we have not shown that example of rearrangement. In E1 there is chances of rearrangement. But the last step where the nucleophile attacks in SN1, where base abstract one. This is the difference. Don't be nervous on this one. Say CH3, CH2, Cl and base. What's happened here? Here, this is same CH, H and CH2. I have just written Cl here in the dot 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 form. When base try to abstract hydrogen, so that bond is arranged in this way and it will try to lose out. That's why I have given dot dot dot. So finally what's happened, this base takes away this bromine hydrogen and that bond is inclined here and chlorine goes out, and that state is called transition state, and it is a single step reaction. So it is a single step and rate is proportional to concentration of two things, one is substrate, other is base, so it is E2. Am I right? And no rearrangement because carbocation has not been formed. Reporting solvent fibers and there is transition state appears. So this is E2 type of reaction. Now very important, again you will get a little of this one in your book. E1CB means electrophile elimination reaction, monomolecular conjugated base. Now what is conjugated base? I am showing you in the mechanism. You see, again we have shown it is two-step reaction. What's happened here? I am just showing you E1, it is two-step reaction. Here CF3, CCA, Cl2 and one base is there. Am I right? So when base is given, this base abstract this hydrogen and you are getting carbanion. So one of the special category of E1CB reaction is that when carbanion is formed, that should have strong minus I group should be attached with it. Otherwise, it will not have any stability because there is negative charge centered on carbon. More is the negative charge centered on it, it will have less stability of carbanion. So if there is some electron withdrawing group attached with it, so this charge will be withdrawn towards other side, other direction by this effect. So there will be stability. Since there are highly electronegative fluorine, 3 fluorine molecules are there, fluorine, 3 fluorine molecule will attract the pair excess electron towards themselves, and thereby the stability will be increased. Hence, it is more stable one due to the high effect with it. We have known earlier that if a carbanion along with the carbanion, if negative groups are attached, minus I groups are attached, these carbanions are stable. Hence it is stable. So this carbanion, what's happened? If you arrange in this way, it is inclined in this way, and then fluorine goes away, double bond appears. You are getting this one. So this is acid. This is acid. I don't know, have you got this concept conjugate acid and base? this is acid. When this, because it is acid, because it lose one hydrogen as proton, the species which lose one hydrogen as proton is called acid. So it is acid. On losing which you are getting negative ion species, and this is base. So this is conjugate acid and base pair. So conjugate acid base pair we have got, and this base means anion is strong or stable due to the presence of strong minus I group attached with it. That's why it is 1E1Cb reaction. SAT, Schiff rule and Hoffman rule. Very often you get this term, but where from this terms has come, you can't actually understand. Actually, this is elimination in beta position. When elimination occurs in beta position or beta elimination, then orientation occurs. Means you have chances to get product. One is major, other is minor. You will have chance to get product. One is major, other is minor. So the empirical rule, it is not exactly experiment. It is empirical rule. That rule provides you the idea out of this product, two possibility of product, which one is major product and which one is minor product. And that proposition was given by Schiff and Hoffman. These empirical rules are called Schiff and Hoffman rules to predict which major eliminated product is major and which eliminated product is minor. And that is very important, and that has always appeared from beta elimination from beta. So Schiff and Hoffman rule has come from beta elimination. So we have got today the link of this empirical rule, Schiff and Hoffman, and we will deeply explain about Schiff and elimination Hoffman rule. Mind that both Schiff and Hoffman rules are concerned with elimination. You be prepare yourself to give the answer, because potassium hydroxide alcohol, whenever you will get above the arrow potassium hydroxide alcohol, it implies that you will get a product which will have double bond. Am I right? So I have told Schiff and Hoffman where there is possibility of getting two product, one is major and other is minor. We will now decide which one is major and which one is minor according to Schiff rule. According to Schiff rule. Now what's happened? Just simple way. See, you don't know anything, but I have written which one is major and which one is minor. Let me explain with the help of Schiff rule. See, first of all, you see, if it is alpha, then this is beta. So you are getting two carbon which are beta, and this is alpha. So the problem, if there is two beta, and if there is two beta, there is a question of major and minor, and that is solved by Schiff rule. So whatever written in the book, I will not explain in this way. I will explain in another way, and which is a brilliant way to get the maximum correct answer. The brilliant way explanation is here that out of these two beta, you choose which beta carbon has less number of hydrogen. That hydrogen will be removed to give double bond. So out of this beta, if it is beta 1, if it is beta 2, so beta 1 has less carbon. Beta 1 carbon has less number of hydrogen. Now that hydrogen, say this is hydrogen and this is beta 1. That beta carbon, the carbon which one, beta 1 carbon has less number of hydrogen, and that beta 2 carbon has 3 hydrogen. So that hydrogen, you release that hydrogen. It is told by Schiff. and in its place you incline the double bond here, you see I have got this answer from this. Am I right? So another answer, you release one hydrogen from more hydrogen carbon having more hydrogen. So here 3 hydrogen, I have removed 1 hydrogen and I have given double bond here. If you write in this way, so I have released that hydrogen from more carbon having more hydrogen. From that carbon I have removed 1 hydrogen and bond has been inclined in this way, where I have got this product. So according to Sijep, the beta carbon which has less number of hydrogen, if you remove that hydrogen and give arrow, inclined arrow is in this way, then that product is the major product. And if you remove hydrogen from beta carbon which has more hydrogen, and that product will be minor product. This is told by Sijep. Hoffman. This is another type of product where major and minor products are explained with the help of Hoffman rules. But there is another fact. The fact is that your base should be a bulky one, very bigger one, very bigger, big one. So if it is 3 degree alcohol, CH3, 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 OH, you remove 1 H, so butoxide, CH3 whole thing 3 COO, tertiary butoxide. If it is base, then that base will attack. So if it itself is a bigger one, then what's happened? It will not preferably attack hydrogen from inner part due to bulkiness. It cannot approach easily. So what's happened here? If it is alpha carbon, then your beta carbon is this one, and that is beta. You are getting 2 beta again. From alpha this side 1 beta, from alpha that type 1 beta. So in that beta, number of carbon is, hydrogen is more than this one. Due to bulkiness of the base, it is no longer used as a nucleophile. It will use as a base, and that base when acts as a base, it will be it should be a bulky one. If it is bulky one, now it will do what? That base will preferably abstract 1 hydrogen. That base will preferably abstract 1 hydrogen from here, because it cannot approach this one due to the bulkiness of this group. Since it is bulky and this surrounding is bulky, it will not preferably attack to the inner B2. It will abstract 1 hydrogen from free end. Am I right? So it is reverse of what we have got earlier is Sijep. So Sijep told beta carbon which has less number of hydrogen will lose 1 hydrogen. Here beta carbon which has more number of hydrogen will lose 1 hydrogen, and that will be inclined in this way and that will go out. So what we get here is CH3. Now see the beauty. In earlier case we got that hydrogen should be abstracted and double bond should be there. Now we are getting that hydrogen beta B1 has more carbon hydrogen, 1 hydrogen has been lost from this one, is abstracted by the base, because it is bulky in nature. If in the arrow, if it is bulky base is given, so you mind that it is base, it is not nucleophile, it will abstract a proton from the less crowded part, that is end is less crowded, so double bonded compound is this is your major product, and that is dictated by the empirical rule Hoffman, hence it is called Hoffman elimination. You can understand very easily, but very often you will be confused with the name. See dehydrohalogenation. Hydro means hydrogen, halogen means X. So what's happened? CH3, CH2, say X, chlorine, bromine, iodine, like this. So potassium hydroxide alcoholic. So what's happened? here is H, am I right? And the reaction will be like this, and bond will be withdrawn. So this is the example. Very often in your question it is asked, what is dehydrohalonation reaction, what is 1,2 elimination reaction, what is beta elimination reaction. This is alpha and this is beta. It is beta elimination, it is 1,2 elimination, it is dehydrohalonation reaction. Now second name is dehydration. Hydration means water. D means loss, loss of water. D means loss, hydro means hydrogen, halogenation means halogen. Loss of hydrogen and halogen, dehydrohalogenation. 1 beta, 1,2 halogenation elimination reaction or beta elimination reaction. Three type of name given from this one. And this is dehydration means loss of water. Mind that loss of water is will give you this, but that is temperature based. The temperature is 170 degree centigrade, because they are on difference of temperature, product will be defined by that. And what is dehydration? That means the reagent concentrated sulfuric acid is a reagent which helps in releasing water, dehydrate. And another dehydrating agent, dehydrating agent, so please learn it by heart. In second year again you will get concentrated H2 SO4 H3PO4 phosphoric acid, anhydride alumina, etc. These are the species when given on arrow. You mind that the substrate will lose water molecule. So concentrated sulfuric acid, H3PO4, phosphoric acid, alumina, etc. are dehydrating agent. So how happens? Say I am showing you the technique. It is not mechanism, I am showing you the technique. So I have written in this way, just you lose water molecule to get the answer. Next one is dehydrogenation. Mind that again you are confused. Dehydrogenation is loss. Hydro means hydrogen, loss of hydrogen. So now what's happened? Again, it is a brilliant example. You please keep it in your mind. In second year again you are going to get. Say you can't imagine the reaction. It is 2 degree alcohol or methyl propanol 2 degree alcohol. It is acetone. When reagent is given in this way, you will never think of the answer like this. Now what's happened here? Dehydrohalogenation. Let us split and let me show what's happened. See, I have told you dehydrohalogenation, hydrogen will be lost. From that carbon, one hydrogen is lost. And from that hydrogen, one hydrogen is lost. How many hydrogen has been lost? 2 hydrogen has been lost. That and that. So you are getting CH3, 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 CH3. And there is one O, that bond will be inclined here, that is double bond O. So you are getting ketone. So this is a very excellent method, dehydration. It is loss of hydrogen in organic chemistry is called oxidation reaction. So copper over 570 degree temperature, it is an oxidation reaction. Where there is a loss of hydrogen, it is called oxidation. So whenever you give copper metal over this temperature, then there will be the oxidation reaction, and that oxidation means what? Means loss of hydrogen. So you are losing hydrogen from here, you are losing hydrogen from O, C and O. So you have lose two hydrogen, means losing of hydrogen is called oxidation. So it is a oxidation, mild oxidation reaction, where hydrogen dehydrogenation is nothing but another name. In entrance exam there is some statement and you are given this is the explanation of this statement is true, this statement is false, a lot of question. Mind that dehydrogenation is nothing but oxidation reaction. Oxidation reaction where loss of hydrogen occurs. Loss of hydrogen occurs. Loss of hydrogen means oxidation. So this is a type of reaction you will get in higher secondary second year. You be confirmed that you will be get in alcohol chapter this reaction, and then you can't understand what's happened. So from today onward you learn what is dehydrogenation, how hydrogen is lost, and if hydrogen is lost, what happens, and reaction is called oxidation reaction. And it is not only copper, there are other lots of things which makes oxidation. So for time being I have got this one, that's why I am relating this to oxidation reaction. Some of the questions I am going to solve from various entrance exam, and also from your class or textbook I have chosen. Very often you will get such type question in your exam. Let me show how we can solve this problem. So when you will get it is alcohol, there will be release of hydrogen from beta, that is alpha. So one hydrogen from beta and one bromine from alpha, so there will be elimination reaction. From this beta 1 and beta 2 carbon having same number of hydrogen, so no matter from where we will remove one hydrogen, so the base will remove hydrogen from here and this will come here and this will be removed. So you are getting CH3 this. So now what is third one? So here you see this is alpha, beta 1 and beta 2. So when there is beta 1 and beta 2 and potassium hydroxide elimination reaction, you remind of SIGEF. So SIGEF tells the carbon having less number of hydrogen, the hydrogen would be lost from carbon having less number of hydrogen. So this is carbon having less number of hydrogen. So your answer will be CH3, CH, one hydrogen you give here, this will be lost and this will be withdrawn and this will be lost. Just I am explaining, you can yourself. Yes, I am showing you. So this is third beta oxide. It is a very big one, big base. So big base. So what is this? Is alpha, bromine is here, alpha, and this is beta 1 and this is beta 2. This is beta 2. Now it will be dictated by Hoffman because your base is a bigger one, bulky one. So bulky one will try to remove one, abstract one hydrogen from the carbon having more number of hydrogen. So it will abstract one hydrogen from here. So you make it 2. So this and this bond will be withdrawn in this way and this will released. This Hoffman product. So next one is because dehydration, loss of water will occur. So loss of water will occur in this way. You make it 2 and there hydrogen and take that hydrogen in this way, OH in this way, and you release. So you are getting CH2 double bond, CH2 plus water. And next and the last one is cyclohexanol. Again, when you will get concentrated sulfuric acid, you recall that it will dehydrating agent, it will facilitate to lose of water. So what's happened here? How you will lose water, I am showing you. Each carbon has two hydrogen, hydrogen, two hydrogen, two hydrogen, two hydrogen, two hydrogen. You are getting in this way. Cyclobutene. And in essence, in presence of excess CH3I. So what's happened? Access to 2CH3 will, this is basic, there is lone pair electron, 2CH3 group will enter here, CH3, CH3 if it is excess. Am I right? So you are getting this. And that will be inclined and that will balance its negative charge. So what you get here is, yes, what you get is this bond, this hydrogen has been abstracted by base, so bond is wooden in this way. You are getting CH2 double bond CH2, and from this part, that part has been detached as alkene, and here you are getting CH3, 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 and this is this, and here you are getting alkene. You never assume to get alkene as the Hoffman product from this structure. So sometimes in entrance exam, very often these questions are being asked. So I hope you have understood or catch the class with utmost patience. With the, I am coming with more interesting topic in the next class. Thanks a lot for watching the class.